Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Future Friday, we're gonna talk about bioplastics. So let's dive right into it. Well, first we have to understand what is the problem with plastic. Well, we use oil for our plastic. So what does that mean? That simply means we are adding new carbon dioxide into the atmosphere. Think of it this way. Our biosphere is like an organic material. Every organic material structure system has a limitation. It's like I can do this much work and rest I will just discard. Like think of your own body as in like you drink water. Your body tries to extract as much water out of it as it can, as much nutrition out of it. But after some time it's like I got to pee it out because I can't handle that. Nature did that same with biological life forms. It's like okay, this much biological life form is creating too much carbon, let's bury it down. That created an equilibrium. Now what we humans are doing, it basically we are putting it out. It's like we are just re-injecting urine into our own system, so to say. So that creates a very serious catastrophic damage, not in one day but over thousands of years. It's a unsustainable thing. Basically every year that will pass will get bit hotter, and after a while when you actually start to take it seriously, it will be too late. So more than enough people at this point in time, yeah, this is non-sustainable. On top of that, that's the environmental side. Let's remove that. Let's talk about economical side, which people care about. We depend on oil wells. Now imagine, even if your country has oil wells, and what happens when the oil runs out? Because we cannot live without plastic. You cannot have a syringe made out of glass. Like the reality is we need plastic. Like we flat out look into medication, look into how the medications are packaged and sold to you. It's generally done through plastic, and there is a good reason for that. Think of it this way: polio vaccines were made very early ago, and they were transported using glass vials. They are very fragile, and in a thermal container which they had to be carried because they had to be kept cold, and you wanted to distribute in Africa and rural parts of India. You did not have the luxury of refrigerators, so you had to put them in a box. Again, not only the box were heavy, it was carrying less vaccine simply because the glass is thick. You're consuming volume just by glass, and it was hell of a headache. Nowadays we don't even give a damn about how the heck we're gonna distribute the vaccines, because we have a material that is 100% waterproof, 100% gas proof, and it's flat out indestructible. That's the biggest headache, but we got it. We got the ways to distribute whatever we need. So be it chips, be it Sprite, be it vaccine. So problem is that we need plastic, we want plastic, and we can even handle plastic in terms of its waste, but we need to find a better source of it. Now, pollution aspect of plastic, I have already made a detailed video about how to make plastic into fuel. It's tangibly simple, but here, even if you are not converting them into fuel, you still have to worry about what happens to the plastic, because for entirety of human civilization, we had in a mindset where it's build it, see how long it lasts. You build a factory, it's it starts to fall apart after 10-20 years. You build a building, it starts to fall apart after a few years. It was always that case. Even if you are building a huge stone structure, over time sand is gonna erode it. So reality was we could not build anything that could last against the onslaught of nature, but we begged for something that could do that, and plastic was the answer. That created a problem. Now we have to think about it. Microbial life form cannot handle plastic, so we have to think about it. And when somebody says biodegradable, you have to understand there are many layers of biodegradable. First would be, is it acting as a physical barrier? Let's say a sheet of plastic, is it still a sheet of plastic? If no, good. That means roots can go through and all that. Just that would be layer one. Then they are the ultimate layer, which we want is ultimate biodegradable. That makes it 100% safe. That simply means it broken it down into its lower components. Basically it's oxidizing it, so at that point it becomes nutrition for plants or microbial life form, whatever have you. That's what we want. However, plastic does not reach that level. Even biodegradable plastics rarely reach that level, and that creates a consequence, simply because when you have long chains of polymers, when you are breaking them down, not every time they will break down exactly the way you want it, and sometimes it will create toxic compounds as a byproduct, which can contaminate groundwater, which you cannot afford. So flat out pollution aspect of plastic is the serious, simply because we have to think about it. We cannot I built the steel structure, and if I stop maintaining it, it will randomly disappear, oxidize into the environment. That will not happen with plastic. Plastic could even become it could even become a bigger headache in the future if it starts to contaminate groundwater. So that's the reality of it. We have to figure out how to handle it at the other end. So why the heck plastic has such a good time destroying nature itself? Well, because it's built out of polymers, which are built out of monomers. Now monomers are bricks, and polymers are like brick walls. That's the whole point. Or you can think of it like a link in the chain versus the chain itself. That's the reality of it. Now, whenever I'm talking about plastic, I'm mostly talking about hydrocarbon. Carbon is the core of it. Hydrogen is the secondary more component out of that. And on top of that, you could add another elements to that. You can add oxygen, nitrogen, in some scenario, copper, things of that nature. You can add to it to improve its performance, reliability, longevity, durability, or you can make it lighter, flexible, more stretchy, whatever have you. Like this is the first nanotechnology we have. It's like where we are tangibly going down to the molecular level and fine tuning. It's like, dude, I want this plastic to be flexible. Okay, add this molecule here, it will make it flexible. Or we are like, hey, dude, I want glass sheet made out of this. Let's say, acrylic out of it. We're gonna do this. Ta-da. Like this is molecular level engineering. We've always seen like what we're gonna have molecular engineering. We had it in 1920s. So that's the reality of it. And the architecture, how you are arranging these monomers and what kind of monomers you are using gives you different outcomes. You must have heard of different types of plastic like PVC, but PET. There are hundreds of other types also, but you get the idea. Like these are the systems have different architecture. Based on their architecture, they have different properties. Sometimes you want something that is more resilient to UV light. Sometimes you want something that is more resilient to temperature. You buy what you want to do. Like, and you can engineer it on a different level. Where it's like, okay, if I add this much copper into this makes it very, very strong. If I add this much nitrogen, it makes it very malleable, whatever have you. So that's the reality of it. This is very deep. Like it goes very deep. Like on a molecular level, we are controlling whatever we want. Now that's the problem, because the monomer is directly made out of petrochemical. The nature does not have any system to handle it, and we want to design it, complicatedly arrange it. We created a basically bottleneck for ourselves. Like how the heck this indestructible thing is going to be destroyed by nature? It can't. So some petrochemical engineers tried some things which were like making it biodegradable, and you must have seen labels like this and marketing like that, like this is biodegradable plastic. So idea was during how we are adding other things to like make it more strong, make it more flexible or desirable to us. How about we add something a little more where we can make it more vulnerable to breaking down? Now in lab result, it showed a very good promise, where it's like, hey, if I add this much let's say nitrogen in this kind of compound architecture, it's like it's gonna break down very easily over time. So it's like, okay, awesome, we can make a plastic which will degrade, not very quickly, but over time it will degrade. However, the reality is after years of using this, it does not work flat out. It does not work in real life. Like flat out companies are flabbergasted with this idea. It's like, it's not they are cheating. Like the science was there and they built it. Like it's not like, okay, plastic does not have the materials that they are thinking. Like you can do spectral analysis. Like dude, it actually has that. Like you can do chemical analysis, everything. Nobody's cheating. It just does not work. And recently companies are trying to like do 2 to 3 year decomposing studies, and it's like, dude, we cannot tell flat out. We cannot tell whether this is a normal plastic or biodegradable one. It makes no difference. It was a basically flopped failed idea. So there are more and more people looking into it. It's like, how the heck that kind of mistake can happen? It was not malice. It was like more of a malfunction, but it did happen. So it creates a problem where it's like, we wanted to build something where it's like, okay, just add this, that makes it more digestible, life form can digest it, everything is good. That did not happen. However, we do have an answer about this. Now answer is very simple. We want to make something out of a chain. Chain is generally made out of monomers. What if we use monomers that is present in nature, aka starch itself? Now starch technically is a polymer, but you get the idea. Now reality is very hilarious here. It's simply because same way in terms of automobile, we first made practical automobiles out of electric vehicles, then we jumped into petrol. Same happened here. Plastics were originally made out of plant materials, starch, and we stopped that because crude oil became so cheap, because crude oil was fractionally distilled, it was making profit, and then this raw byproduct that nobody could do anything with, it could make plastic. And because companies just wanted to get rid of that petrochemical aspect, it's like, yeah, just buy $1 for 10 tons or things of that. Again, I'm exaggerating, but you get the idea. Like flat out bio created plastic could not compete with the price of petrochemical one. That's why we forgot about like this whole aspect of engineering that we did, and some new architectures were created based on petrochemical itself, because petrochemical has ludicrously long chains. Nature chains are long, but petrochemical is like on a different level. So arranging this basically polymers differently, you can get multiple different blends out of it. And you must have heard this term again and again, especially in plastic circles, where it's like, okay, this blend makes it more resilient, this blend makes it more UV resistant, this blend makes it more flexibility, this blend makes it, like there are blends. That's the whole point of plastic. Plastic is a molecular engineering marvel. So we utilize something that biology can digest. How? Simply, we are utilizing glucose itself. Now glucose is the link in the chain. Now you attach a long chain, you get starch. Now starch, you can mix it with other things, you can chemically tune it, same way we do with other things, because inherently it's also a hydrocarbon with a bit of oxygen. So utilizing this, what we call dehydrating it, basically we are removing oxygen and hydrogen out of it, so we get water out of it. So that's why we call it dehydrating it. You can fine tune it, and we create something known as PLA out of that. And I'm reasonably sure you must have seen or at least utilized PLA once in a while in your life. Now it's a real thing, it works, it's biodegradable, and it's not biodegradable in the sense it's like mixing something else. It's inherently biodegradable. It's not like we are tampering the molecular chain. The molecular chain itself is biodegradable. So it works, and it has been a staple of food, basically food-based plastic products for a very long time. And I'm reasonably sure anybody who's working with 3D printers also knows about this. So reality is we have the solution. We had the solution. It's just that we did not have the economics. But the economics factor is coming back, because nobody wants to be reliant on like, hey, what happens if Russia charges too much for their oil, or some other countries charges to, or somebody triggers a war for that. Nobody wants that. Like nobody wants that. And every Tom, Dick, and Harry is starting to feel the reality of it. Like, dude, plastic is becoming an indestructible thing. We have to solve it. So what we can expect in the future? Now, this is one thing that you have to understand. There are many people who are becoming very anti-carbon now. Hating carbon is stupid, simply because carbon is life. Carbon is the part of life that makes life itself possible. We are made out of hydrocarbon itself. So if we can make it cycle, that's basically how nature intended. Make it a cycle, we will become what we call imbalance. Basically, we are not fighting with it. We are just going with the flow. That's all we have to do. We do not have to like change our way of life, become more miserable. No. Like people are saying like we're gonna replace plastic with what exactly allows you to transport chips? Flat out nothing. Like there are so many food products that will flat out stop transporting. There are so many medication that will flat out stop working if you do not have plastic. PLA has been put inside humans also. It's that safe. Like we actually, and it takes time, like around 1 to 2 years for our immune system to destroy it. But that's the amazing aspect of it. Like for bone implants and all that, you want it to slowly erode away, not just like magically break away. Otherwise the bone will break again if you do that quickly. So all we have to do is not to like, okay, remove plastic, let's become carbon neutral. Whereas like we are not adding new things, we are just like cycling, we are improving the cycle, we are just flowing with the flow. So bioplastics can be made. The reality is there. We know it, we have been doing it, and so far Brazil is doing a very fantastic job, because they have a sugarcane industry and it's huge, like huge, and I truly mean that. So what they do, they take the sugarcane and it's like, okay, we got the sugar out of it, basically what they sell to people, sweet, and then they take fuel out of it, ethanol, which they can depending on what they want, they can directly run ethanol in the cars or fine tune it to make it gasoline. That's up to them. Then they have a byproduct. That byproduct can be directly burnt into a power plant to give electricity, or they can make plastic out of it, whatever makes them more profit. So that's the reality of it. So if we can have a source of starch, aka seaweed, aka algae, anything that you can think of that can give us starch, we have the chemical engineering where we can like, okay, take the starch and make it into a real thing. And I mean, we have doing this with corn, for crying out loud. I have provided lots of video down below, you can see that. So reality is, we want plastic, we need plastic, we just have to make it more efficient. We have to carbon neutralize it. Basically, like, we're not gonna add new plastic, and ideally we want to make it out of a chain which over time, again, it's not gonna break in 1 day or 10 days, but over time it should break. It should not become like, undestructible garbage patch in the Pacific Ocean. We don't want that. So future is quite bright about this, and cost has started to come down, specifically when people are starting to combine the technologies. Like rather than making like growing corn and making plastic out of that, that's not efficient, because like again, you are consuming something primary. Here people are consuming something secondary. That's the whole point. We want to make plastics out of secondary waste. It's like people are working with fish, people are working with seaweed, people are working with algae. The idea is you want to use as much secondary thing as you can. Like some people have figured it out how to use that with agricultural waste. So that's the amazing aspect of it. If we finally fine-tune it, figure it out, and where we can have like extra benefit, hey, instead of creating this waste, we are creating plastic out of it, which is completely carbon neutral. Awesome. What happens if that plastic goes into the sea? She will destroy it. Awesome. And we don't have to change our way of life, where we like, yeah, I need vaccines, I want people to live, and I lived in a world where I have seen people with polio. I do not want that puppy to come back. So that's the reality. I can see future very clearly and very bright. Plastic would be there, it will be just greener. So this was my presentation on basically bioplastics. I hope you liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I'd urge you to press dislike, press it twice to show me extra disappointment, and please leave a comment because I try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.